So, our learning target is that we can solve word problems that involve quadratic equations, and here's our word problem. Rachel throws a ball upward at a rate of 20 meters per second from an initial height of 2 meters. The height of the ball above the ground can be approximated by h is equal to negative 5t squared plus 20t plus 2, where t represents the amount of time in seconds since the ball has been released. So units that we're talking about time and height in seconds and in meters. So in our quadratic here, h and t, we have inputs and outputs. Inputs and outputs, they all make a coordinate point. T and h, where t represents time and h represents height. So I would take these notes on your white paper because this is what you're going to use to do your pink sheet on your own. Right. Each time we graph a quadratic, it's going to make a parabola. So I'm going to do a sketch of a graph, and I'm only going to do one coordinate of it. Before we graph it, let's make some labels. So this axis is going to be our t-axis for time. And our vertical axis is h, and that's for height. So our friend Rachel, she's 2 meters up and she throws a ball. So Rachel, if this point at the corner of our graph is 0, 0, Rachel is like 2 units or 2 meters up from that. So this dot is Rachel right here. 2, 0. Or sorry, 0, 2. I did that last hour also. It has to be 0, 2. All right. Rachel throws a ball in the air, and then it comes back down to the ground. So the path of the ball will look like it goes up, up, up. It reaches a point, and then it starts falling back to the ground. So you should have this parabola on your graph, because from this, we're going to get a bunch of information out and answer all those questions that are on your sheet. On this graph we can find out where our maximum height is. Our maximum height is at the vertex of our graph, all the way up here. This black dot at the top. This is max height. This maximum height point has units on it. We're going to find a number for t and for h. That's going to go in here, in these 2 blanks. Excuse me. Don't worry, I'm okay. Another point that would be interesting to find is this point at the bottom. This is where it returns to the ground. And that's going to have a point too. We know it's at the ground and we know it's going to be a height of 0. So this is going to have a blank, comma, 0 feet as a point. And that blank is going to be how many seconds it takes to reach the ground. So now we're going to flip over to Desmos, and we're going to type in that quadratic that I have highlighted in yellow. So flipping over to our graphing Desmos. So we're going to type it in just as we see it. So we're going to type in, you can just use your keys on your computer. You would say H is equal to -5. So you can use like your little dash mark and it counts. -5. And then to do t squared, hit your t. Everybody's got to do this step by step. Hit your t, hit your shift button, and hit 6. And then your little cursor is going to jump up above. And then you're going to type 2. So it should look like that. So once you type in H is equal to -5, hit your shift key, and then hit 6. And then type in 2. And then you got a cursor over 1, so your blinking line is back to where it started. And then we type in the rest. Ooh, I didn't put my T in here. That's fine. T. So it should look like that. And then you put plus 20t plus 2. All right. Does anybody need any help doing that? From what I can see from here, the graphs, everyone has at least a graph on there. So now we're going to answer the first question. When does the ball reach its maximum height? So look back on your notes, that's the little picture you just drew. Max height is your vertex. It's at the very top. So you can scroll using zoom in or zoom out, or you can use like the touch screen on your Chromebook to go find the very top of your parabola. And if you touch the top of it, a point should pop up. There's a little gray dot, and then a point will pop up. Sage, you forgot the negative in front of your 5. There you go. All right. So you have two numbers. You have 2, 22. Does everybody get 2, 22 when they hit the point?
No.
Yeah. So this right here is the highest that the ball will reach. 2, 22. And remember, both of these numbers have units on them. 2 stands for our t value, so how much time has passed. 22 stands for meters, how high it is. So your first number, I'll say it again. Your first number goes with your time. Your second number goes with your height. So flipping back to our notes, our max, if I want to fill in these blanks here, 2 and 22. This will be 2 seconds and 22 meters. So we can answer those first two questions. When does the ball reach its maximum height? Well, this is the path of the ball at its maximum height. 2 seconds have passed. So for question number 1, we'll write after 2 seconds. Units are important on these. You always want to have units with your answers. If you just say 2, I wouldn't give you credit for it because 2 doesn't have any context behind it. It's a word problem, you need units.
Wait, can you move?
So the second question, what is the maximum height that the ball reaches? Well, after 2 seconds, it reaches a maximum height of 22 meters. So then we can just write, what is the maximum height the ball reaches? 22 meters. All right. Question 3. When will the ball reach the ground? We're going to go back to our Desmos graph. And the path of the ball, and this is where I'm throwing it from, it's in the air, it's in the air, it's in the air, it's in the air. It reaches the maximum height, and it starts falling back down to the ground until we have a height of 0. So down there at the bottom, we see we have 4.098, comma 0. That means it has taken we can say 4.1 seconds for the ball to travel up and all the way back down to the ground. You know you're at the ground because we have a height of 0. We're at 0 feet. So we go back and we fill in our notes, kind of the fill in the blank that we've been doing. It returns to ground after 4.1 seconds. You guys ask questions during work time, I'm not answering them.
Damn. Where'd you get 41? 41.
Point exactly. So how high will the ball be after 3 seconds? We're going to go back to our graph. If on Desmos, if you follow along, if you kind of cursor, follow your little, if you use your arrow and you follow along the red line, both your numbers will change. Remember, your first number has to do with time, and then your second number has to do with height. So if you get your first number to equal exactly 3, so you scroll until it's 3.0, and you try to find it, 3 point, we get 17. So that means after 3 seconds, it is 17 meters in the air, or meters high. All right, so we were going to ask, how high is it after 2 seconds? We would find where our first number, our t value is 2, and write down our output. So I can add that piece of information onto my graph, make a new dot. After 3 seconds, it's 17 meters high. So on the homework, it's going to ask you, kind of each problem will ask you one of these 4 questions. Each problem doesn't ask you all 4, it's just 1 per question. All right. There's 2 things we got to change on the homework. Of course, it wouldn't be me if I didn't make a few typos and whatnot. So this will be nice to put just at your bottom of your notes so you can go back and reference, or you can put it on your practice sheet. The first one, a typo on the first problem, it's really good. It should be, there's an equal sign in front of the 20, it should be a plus 20. On the red, on your pink worksheet, number 1 should be plus 20.
It is plus 20. Oh, is that the execution? Let me see it.
On number 5, I think it's number 5. Let me just look at yours. On number 5, it should be 32t. And then one thing, when you type all of them in, on each equation it says h and then t in parentheses. Just type h is equal to. Don't type h parentheses t. Just say h is equal to like we did in the first example. So your answers for all of these problems should just be a number with units attached to it. If you don't have units on it, I'm going to tell you to go back and add units. You need a number and a unit for each of these, and everything you can just do from looking at your graph.